So, I'm Daryl. I've met half of you last year and the other half today. Hi. So we live in a rather hot climate. And so I thought I'd do a talk about how controller boxes go with power supplies. I hope everyone knows what a power supply is. If you don't, then perhaps you're in the wrong place today. But they're basically 240 volt in and then some DC volts out. What you may not know is that they're not 100% efficient, and what they lose in efficiency they put out in heat. And so I picked up one of my power supplies, happened to be a Meanwell 320 watt 12 volt supply, and looked at the data sheet. The cheap Chinese ones you won't find a data sheet for, but this one actually had a data sheet, and it says that it was about 88% efficient. But that still means that your box has to deal with 40 watts of heat, which if your box is all sealed to keep it waterproof, that could be challenging. And there's a photo that I found on the internet of a box with two power supplies crammed into a little box with no airflow. I hope that's no one's box here. If it is, my apologies, not intentional.
Oh my God!
I knew it, Steve! But that frightens me a little bit. That's one of my boxes from my Megatree. It has a couple of vents, and I thought I'd do some testing with that. So at some point in the past, I bought an infrared heat camera attachment for my phone, which lets us see heat maps of whatever we pointed at, really. And so the first thing I pointed at was the cat. In the middle of winter about this time last year, and apparently the cat was about 14 degrees at the time, so probably not a very happy cat. You can point at all sorts of things and discover things that you didn't necessarily expect. So for instance, the picture on the left is a couple of my fuse blocks. And I figure if my fuses are running at 64.2 degrees, they're probably going to blow. So it's useful to know. And the strip on the right is 60 pixels per metre, a 5 volt strip. And I must say I didn't expect that to run quite as hot in the middle of winter as it did just there. But back to these boxes. So this isn't scientific. Like, I tried to keep things all the same and just change one variable at a time, but your mileage may vary. So I had a sealed box, I had a vented box with a couple of vents in it, but no fans on the vents, and then I had an extracted box, which is with the fans running, one to suck air in and one to push air out. And so I put about 300 watts of load on this power supply and ran it for an hour. So these are the results from the extracted box. On the left is before we started, about 19 degrees, because it was May when I was doing it, not terribly hot inside. And by the time I finished, the box is showing about 25 degrees. That seems perfectly reasonable. You can see on the right-hand picture at the top vent in the bluey colour must be the cold air intake, and then the one on the bottom right with the 25 degree next to it is the hot air output. And so then I disconnected the fans and ran it again. And the box was a couple of degrees warmer at the start because it had been warmed up from the previous test and not fully cooled down. But what we see with the fans turned off is that the box reaches a temperature of 38 degrees, which is, you know, not that awesome. And then I sealed up the box. And whilst at this point the results look pretty similar, I think if we go to the next slide, we can see that up in the top right of this one, that the box was actually reaching over 50 degrees in certain parts of it. And because this was only a test rig, I hadn't really dimensioned any of my cables properly. So you can see the cable on the right-hand side was running at 40 degrees at this point because it wasn't high enough gauge for what I was pushing through it. So as I said, it was the middle of winter. It's about 15 degrees inside. Now when I start my show in the middle of summer, it's often 30 degrees or more outside still. The sun's still up, sometimes even. So let's take all of this data, let's assume that it's all fair, and let's just add 15 degrees to all the numbers to try and see what summer might do to it. And what we basically see is that the blue line is the sealed box, and after an hour, in theory, your box could be running at 65 plus degrees inside. Now, I don't know at what point these power supplies shut down, but what I do know is that they get less efficient as the heat goes up, and so their ability to provide power reduces. So you need to vent your boxes. You know, you could just not put a lid on it and hope it doesn't rain. That's one strategy. Probably wouldn't recommend that one so much. We can see a variety of different vents that various people in the community are using. The photo on the bottom left is actually showing a fan attached to the vent on the top left to try and force the air in and out of the box. You can do all sorts of things. So in this case, these power supplies are back to front airflow rather than the typical power supply that just pushes the air out the top of it. And then you can, you might need to make some baffles or something to make sure the hot air actually leaves the box rather than coming back around the air intake. Coro makes a pretty good baffle if you need to make a baffle of some description. But what I'm trying to say is you've got to think about these things. Don't just wait till it fails or catches fire or something nasty like that. If your box is in the shade and you can feel it warm on the outside, then it's going to be very, very warm on the inside. And that just adding holes without fans or vents is not going to necessarily solve your problems. So pretty much ignore at your own risk. And so what I was going to demonstrate around the room now is this thermal camera quickly, and we can point it at whatever's lying around, and you can get a feel for how it works. Yeah.
Does this mean you're going to everybody's show to test it for them? To see who...
No, but anyone that's got a box here, we can...
Where do you get those vents from?
The David AVD has a page on his wiki that shows some ideas.
DO Share it's called. If you Google DO Share, you'll see he's got multiple tabs on there, and one's it does show an Australian supplier for that left-hand one.
Yep, the ones on the right. The ones on the right are simply from Bunnings. They're rainwater tank stuff.
Ones on the left, they've got the screw in on the outside, 60mm hole, bore the hole straight through, screw it on the back, and the fan actually just bolts straight onto the back. They're very good.
Yep, I'm waiting for Phil to make a design available. But this is basically how it works. And usually laptops are pretty warm just below the screen. Yeah. It wasn't cheap. It was a couple of $100. So you'd want a use for it. You wouldn't just want to buy it. Wouldn't want to just buy it for this. I bought it to test where my insulation was missing in the ceiling without having to go on the roof.